Hello everyone, and welcome back to another PCB overview video, basically. I noticed that, well, there's basically no, PCB overviews for the reference PCB that Nvidia used for basically all the high-end GTX 700 and GTX 900 series cards, including the Titans. So, you can see here all the cards that use this PCB, if you get the reference version. And basically I'm gonna, go over what the PCB has on it. You can see here I've already written some stuff on it because I also want to go into why this PCB is so bad. So this specific card right here is a GTX 780 Ti. There are a few differences. So basically these cards over here are gonna be very, very similar to what you see here, whereas the Titan and the 780 have a certain difference, which is that these green marked power stages do not exist on them. But they do exist on the 780 Ti and everything that comes after that. So yeah. So basically the reference PCB has two very big problems that make the cards that use this PCB fail a lot. The first issue is these memory inductors. And basically what happens with a lot of these cards is that these inductors burn out. And it's not something connected to the inductor making it burn out. No, it's just the inductor itself burning out. And that is probably, there's no confirmation on this, but the most likely reason why this happens is that these inductors are just under-spec'd and they cannot handle the amount of current that the card regularly just shoves through them. And eventually, if stressed enough, these inductors can just burn out. However, there's another thing that is far more likely to happen, and it has actually happened to this card if you look at this. So the other big problem that this PCB has is the VRM for the core is just not good enough. Let's get into the Vcore VRM. So, Nvidia really put a lot of work into this PCB to make it look like an 8-phase, but it is actually just a 6-phase. And you can see this from several things. So the first thing is the Vcore Pwm Controller, which is an NCP4206. That's just a 6-phase controller. It doesn't do more than 6 phases. And it also does up to 1.5 MHz switching frequency, even though, we're not gonna run that ever. But you do have 8 power stages in your VRM, but then you have only 6 inductors and that 6-phase controller. So what are these 2 extra power stages doing? Well, they are 12-volt current balancing switches, essentially. So what could have been done with just a very simple discrete MOSFET, Nvidia just used a 50 amp power stage for. So all what these do is just balance the 6 and 8 pin and maybe also the PCI Express slot, so that when one is drawing more current than it should, it just switches the connection over for a given phase, and now the load is distributed to the other connector. That's all they do. They don't do any current for your core. That's only done by the 6 power stages for your 6 Vcore phases. So very good budget decision on Nvidia's side here. It really baffles me. This is a 50 amp DRMOS. 12 volts at 50 amps, that's way more power than this will ever have to handle. So they could have just used some very, very cheap discrete MOSFETs for that. Or even better, just not bother with current balancing at all and use those extra MOSFETs or use those extra power stages for 2 more Vcore phases, because then the card would have probably actually been kinda decent. But no, we get a 6-phase Vcore. So, I've already said these are 50 amp DRMOS components or a very dumb kind of power stage. And there's actually 2 kinds of DRMOSs that you're going to see used on these cards. So this card specifically, if we zoom in, you can see it is using the SiC 780 power stages from Vishay Semiconductor. But I've also seen 780s and 780 Ti reference cards, or also 980 Ti's, that opt instead for the FDMF 6823Cs, which are basically the same thing, just made by Fairchild instead of Vishay. So both of these are 50 amp DRMOS components, and yeah, it's not that these things in itself are bad. These are pretty decent. The 780 Jetstream uses these 6823Cs, but 8 of them, and that VRM is actually pretty decent. But since we have 6 of them here, that's the actual issue. So it's not the parts are bad, it's just we don't have enough of them. Because 6 of them, well, 6 times 50 amps, that's 300 amps. That's not a lot of amps, especially for 780 Ti, which, like, a 780 Ti has insane power draw. So yeah, and I did actually make a test with this very card. Like with the stock BIOS, the card mostly runs around 1 volt and consumes about 250 watts of power. That's 250 amps of the maximum 300 we can handle. And the thing with the DRMOSes and power stages is, they say they can do X amount of amps, but you wouldn't actually ever run that through them, because at that point they would get so inefficient that they're gonna overheat instantly. Which is why when you go into the datasheets of 70 and 90 amp power stages, the efficiency rating stops at 60, because no one's ever gonna run more than 60 amps through these. So yeah, stock, the card is already very, very close to maxing out this VRM, and when you overclock, well, it's not that far to actually max out the 300 amps, or maybe even overdraw it. I think I actually did overdraw this VRM on a 780, because I did have 350 watts of power consumption, and I don't remember what actual voltage, but if it was 1.2 volts, then yeah, that probably maxed out the VRM. So yeah. So basically what this PCB does is it has its power stages die very, very often, which you can see proof of right here, because this power stage did actually die on this card, and now it's a 5-phase. Now it's even worse. Which, yeah. So that's basically the problem with this PCB. The biggest problem is just you don't have enough DRMOSes to supply all the current that the core needs, especially on the 780 Ti, but also all the other cards as well. And yeah, these power stages just die a lot. And when they die, they short 12 volts to the output, and if you don't have a good power supply, that's bye-bye core. So yeah, not good. And then there's of course the other issue with the memory inductors burning out, but I haven't seen that as often. Though it does happen with some sort of consistency, so that it is a problem of this particular design. So yeah, this PCB really sucks, and I actually think that this is the worst PCB that Nvidia has ever put out. Like, a lot of people seem like, and from what I've seen, a lot of people seem to think that the GTX 480 is the worst reference PCB Nvidia has ever put out. But as far as the 480 goes, it's actually pretty, like, it's not that bad if you ask me. Like, of course you can't go really high voltage on it, but on Fermi, you don't really go high voltage anyway, because they like cooling way more than voltage. Whereas Kepler is very, very easy to overvolt and still have gains, because Kepler isn't as temperature sensitive as Fermi is. So you can crank the voltage more on these before you run into diminishing returns. And yeah, so both the 480 and this PCB have 6 phases, but this one is opting for 50 amp DRMOSes, whereas the 480 is opting for discrete MOSFETs, which I don't exactly have in my head how powerful they are, but I think they can do more than 50 amps per phase. So yeah, this is actually kinda worse. It's probably more efficient, but in terms of maximum current handling, this is probably worse. So yeah. Don't overvolt these. Just don't. Like, if you have one of these PC, like, okay, you can overvolt them if you have some really good cooling on those power stages, because the more you cool them down, the more current they can handle. But if you just have like a standard air heatsink or something, and the base plate is not really good, then yeah, please don't overvolt these. It's probably gonna die. It's not gonna stop me from overvolting this, but basically when I run this card, I am very, very aware that this might be the last time this card runs anything. So yeah, if you have one of these cards and you're not okay with them dying, don't overvolt these. Just don't. Maybe even undervolt them. Could do that. But yeah, so let's get into some more things about the PCB. So we have the PEX rail down here. The actual chip generating this rail is on the back, but you can probe this inductor for the PEX rail. And then back here, I wasn't able to confirm, but I think it's the only thing that could be 1.8 volts on this PCB. I am not entirely sure. It could also be 5 volts. So don't take my word for it. But I think this... Oh, sorry. I think this over here... I think I measured this, and I think it was actually a 3.3 volts regulator, which is weird, because you have 3.3 volts right here. But I've seen this before, that that's just, even though you get 3.3 volts from the PCI Express slot, the card just converts 12 volts down to 3.3 for some reason. And I think I've measured that this is 3.3 volts. So, yeah. But this might also be 5 volts. I am not sure on that. I would have to measure. But like the thing is, if you have the card in hand, you can just measure yourself, so it's not really a big deal. Yeah. So then another thing, we have an INA 3221 on this card. It is connected to the 5 shunts that I've marked here. Kepler is pretty easy to power mod. You can literally just remove the INA 3221 and the power limit is just going to be gone. But if you would like to still have some sort of power measurement, but still no power limit, you can also just use Kepler BIOS Tweaker and give yourself a 1000 watt power limit. And then the card will just not power throttle, but you will still have your power consumption reading in GPU-Z to get kind of an idea how close the VRM is to blowing up. So, yeah. And also, I think if you just remove these capacitors, that also removes the power limit, and you can keep the INA 3221. Oh, I just broke that. So that. Yeah. And then, well, the last thing we haven't talked about is the memory VRM itself. We talked about the inductors, but yeah. It's using some discrete MOSFETs and a rich tech controller that I cannot identify very easily. These two-phase rich tech controllers, they have a marking on them, but if you Google that marking, you get nothing. You need a basically a decoding thing from rich tech. I have one of these, but well, it's another case of if you really wanted to mess with that, you would have the card anyway, and you could also just decode that yourself. So, because this VRM is not really that important, it's a memory VRM, so there's that. And yeah, so it's basically it for the reference high-end 28 nanometer PCB from Nvidia. And yeah, it's pretty bad. I think this is the worst Nvidia has ever put out. Well, actually, the reference 1070 PCB is also a contender for that, because that has a 3-phase, if I remember correctly. But yeah, this, like, yeah. So 28 nanometer, especially the 780 Ti, can have some insane power consumption if you overclock them. And this PCB is so close to max, even at stock, that, yeah, like on Fermi you can do something with the reference PCB cards. On Kepler, this is just gonna blow up. Like, this will just blow up. You can't really do anything about that. And yeah, it makes me really angry that Nvidia included those extra 12-volt current balancing DRMOSes. Like, you're already paying for the power stage, which is that is the most expensive thing in every phase. So you're already paying for the most expensive component of a phase. The only thing you would need is another inductor, and you would upgrade the NCP 4206 to a 4208. That's all you would have to do to turn this into an 8-phase and probably a pretty decent PCB. Because at that point it would be better than the Gigabyte custom 780 Ti, because that has an 8 phase with 40 amp power stages. So if you would have 8 of these, you would have 10 amps more per phase. So yeah, it's bad. It's very bad. This is why. Yeah, gonna end the video here. So I hope you were able to somewhat enjoy this at least. And yeah, this card here is probably getting E-powered, or maybe I'm just gonna replace that missing power stage and see how far I can push it before it blows up for science or something. So yeah, yeah, not really. Thank you all for watching, hope you enjoyed, and until next time, goodbye.